Hey everyone, and welcome to This Explainer. I'm so thrilled to have you here today because we're about to embark on a truly exciting journey. We're going to map out exactly what it takes to transition from clicking buttons manually on a trading screen to architecting a fully automated quantitative trading system. If you've ever wanted to know how the pros build resilient, lightning-fast, and completely automated tech stacks, so they can literally sleep while their code trades, well, you're in the exact right place. So let's dive right in by asking a massive question. It's the core question that separates standard retail trading from institutional-grade, low-latency execution. What actually makes a system truly real-time? Is it just having a super-fast internet connection? Well, no, not at all. As we're going to see, true real-time execution in the high-stakes world of algorithmic trading means processing hundreds of thousands of market updates every single second without a single hiccup. It takes a flawless combination of software architecture, programming languages, and physical infrastructure. Here is our blueprint for today's explainer. First, the Algo trading blueprint. Second, platforms, specifically mastering MetaTrader 5. Third, backtesting your trading strategy. Fourth, advanced engines like Quant Connect Lean. Fifth, infrastructure, covering VPS and WebSockets. And finally, deploying with risk control. All right, Section 1, the Algo trading blueprint. Let's get on the exact same page about what this ecosystem actually looks like. Before we start stocking all this complex tech, we really need to nail down what algorithmic trading actually is. At its absolute core, it's all about translation. It's taking your human ideas, your strategies, your risk tolerance, your specific entry and exit criteria, and translating them into a strict set of rules for a computer to follow. Think of it like setting up this massive, intricate line of dominoes. You spend all your time meticulously building the rules, but once the market triggers that very first domino, the computer does the rest flawlessly. And by doing this, you completely remove the two biggest hurdles in manual trading: human latency and emotional decision-making. Moving on to Section 2, platforms and mastering MetaTrader 5. If you're just starting out, you need a robust environment, which brings us to the absolute industry standard for retail algorithmic traders. MT5 is a massive leap from older platforms. Most notably, it gives you 21 different chart timeframes. We're talking hyper-specific intervals here, like 2-minute, 3-minute, and even 8-hour charts. When you combine that level of granular detail with over 80 built-in technical indicators right out of the box, you are handed an incredibly powerful environment. It lets you refine your mathematical models and trigger your automated strategies with a level of precision that just wasn't possible in the past. But here's the thing. To actually automate within MT5, you can't just type in English. You gotta speak the machine's native tongue. Enter MQL5. This is a domain-specific programming language, which means its entire existence is dedicated purely to navigating financial markets. It's object-oriented, it's structurally very close to C++, and it's vastly more powerful and faster than its predecessor. That speed is exactly what allows for highly complex math computations to happen right on your chart in real time. So what can you actually build with MQL5 inside the meta editor? There are 3 core programs you really need to understand. First up, expert advisors, or EAs. These are your active traders. They're fully automated bots bound to a chart that patiently wait for specific events to trigger trades, 24/7. Second, custom indicators. Think of these as the watchers. They don't place trades. They just visually signal market events based on your unique math. And finally, scripts. These act like one-time executables, which are perfect for things like instantly closing all your open positions with a single click. Okay, Section 3. Backtesting your trading strategy. Once you've got an idea and maybe a basic bot, you absolutely must test it on historical data. Now think about the stark contrast between two heavyweights in Python backtesting: Backtrader and VectorBeat. Backtrader is fantastic for beginners. It's incredibly easy to use, it's got mature documentation, and it smoothly feeds data in bar by bar. But if you want to optimize a strategy by testing thousands of different parameter combinations, VectorBeat is the undisputed king. It gets this blistering speed by using Numba-compiled components. Basically, it translates Python into machine code, giving you processing speeds that take mere seconds to accomplish what might take other libraries hours. It's totally wild. Section 4. Advanced engines, specifically Quant Connect Lean. What if you want to push past the standard frameworks and integrate your code directly into an institutional environment? Created by Quant Connect, Lean is a massive step up. It's an open-source, event-driven algorithmic trading engine. And what makes it so incredibly special is that it allows for a seamless local cloud hybrid development environment. This is a total game changer. You get the comfort of coding and debugging locally on your own laptop using Visual Studio Code, combined with the immense computing power of the cloud to test massive decades-long datasets before you ever deploy live. The absolute beauty of Lean is its highly modular architecture. Honestly, it's just like playing with Lego bricks. Because things like data feed sourcing and transaction processing are isolated modules, you can build your core trading algorithm just once. Then you can simply swap out the brokerage plugin or change the data feed plugin without ever having to rewrite your actual trading logic. It is meticulously engineered for ultimate flexibility and scale. All right, Section 5, Infrastructure looking at VPS and WebSockets. This is where your code finally leaves the safety of your local machine and steps into the live, high-stakes market. If you're running an automated bot, you cannot rely on your everyday setup. Seriously, hosting an automated trading bot on your home Wi-Fi is like flying a passenger plane with a TV remote. A single dropped signal or a tiny power outage is a financial crash. You absolutely need a virtual private server or VPS. The steps are pretty straightforward. Choose a provider hosted in a data center physically close to your broker's servers, connect remotely, install your platform, and configure your EAs. This guarantees 100% uptime and drastically reduces slippage by keeping execution times down to mere milliseconds. But what if you outgrow retail platforms entirely? When data engineers build custom Python systems connecting directly to Exchange APIs via WebSockets, milliseconds just aren't fast enough anymore. We're talking about processing market updates in microseconds. To put that into perspective for a second, a single blink of a human eye takes about 300,000 microseconds. In this high-frequency realm, a blink is an absolute eternity. Achieving sub-millisecond latency becomes the ultimate goal, and system resilience is everything. To hit those mind-bending speeds in Python, you can't just write standard code. Engineers have to use highly specific optimization tricks. They use asynchronous to handle multiple WebSocket data streams concurrently without the code blocking itself. They implement hyper-efficient data structures. And crucially, they use memory pooling, meaning they pre-allocate memory objects. Why do they do this? Well, when standard code tries to clean up unused memory, a process called garbage collection, it essentially freezes the system for a fraction of a millisecond. In algorithmic trading, that microsecond freeze can literally cost you the trade. Which brings us to Section 6, Deploying with Risk Control. Everything we've built so far leads to the single most critical aspect of quantitative finance. This crucial reality is captured perfectly by data engineer Jose Acosta. You could have the fastest VPS in New York, the most perfectly optimized vector beat parameters, and flawless Python websites, but it is all completely useless if you don't rigorously forward test. A real system requires dedicated paper trading, meaning running live with fake money to make sure your historical backtest actually matches real-world reality. This must always be followed by a very gradual deployment with hard-coded risk controls and strict stop losses to protect your capital. So, we've covered the complete blueprints in this explainer today, from MT5 and MQL5 through Python backtesting and the Lean engine, all the way down to low-latency VPS infrastructure and risk management. You literally have the ultimate algorithmic tech stack laid out right in front of you, and the tools have never been more accessible than they are right now. So the only thing left to ask is, what will your first automated strategy be? Thank you so much for joining me on this explainer, and I really look forward to seeing what you build.